A simply supported beam is subjected to two forces. PB is equal to 7 kips. PC is unknown. We are looking for that. This beam is made of wood with the allowable shear stress of 850 psi. The cross-section of the beam is a rectangle with a width of 2 inches and height of 6 inches. If PB equal to 7 kips is applied on this beam, what would be the maximum allowable force P sub C that the beam can take? The length of the beam is given, also the distance of each of these forces to the supports are provided. Before doing the calculation, again, let's plan a solution for this problem. In this case, the maximum allowable shear stress is given, 850 psi. The section is a rectangle, and the forces, one of them is given, the other one is not, and I need to determine that. In order to solve this problem, we need to ensure that the maximum shear stress in the beam is not exceeding 850 psi. That means that we need to determine the maximum shear force, the maximum Q, also determine I and thickness, and determine shear stress, and make sure that shear stress is not exceeding 850 psi. Alright? The first part is determining the maximum shear force from the shear diagram. Let's start with determining the reaction forces in this case. Sum of the moments about A is equal to 0. That means that PB multiplied by distance of B to A, which is shown by L sub AB, plus PC multiplied by distance of C to A, which is shown by L sub AC, has to be equal to D sub Y, the reaction force at D, multiplied by its distance to A, which is shown by L sub AD. Lengths are given, so I can plug them in. Also, P sub B is 7 kips. There are two unknowns that I can't solve on. But I can write down the reaction force in terms of this unknown force, P sub C. That would be equal to 3 plus 6/7 of PC. Now, we are going to write down some of the forces in the y direction equal to 0. That means AY plus DY are going to be equal to PB plus PC. And from that, we can determine how much is AY by plugging in the values in terms of P sub C. Now let's draw the shear diagram. At the left side, shear diagram would have a value equal to that reaction force. So that is going to be 4 plus 1/7 of P sub C. It is going to remain constant all the way to this point. At that point, there will be a jump downward with the magnitude of P sub B, which is 7 kips. So that would give us -3 plus 1/7 of PC. And after that point, again, there would be another jump with the magnitude of P sub C. And because that is downward, I'm going to use negative sign for that. That would give us -3 plus 6/7 of PC. And once we get to this point, it would get back to 0, which shows the calculation is correct. So what is the maximum shear force in this case? We don't know. There are 3 areas, all are a function of PC. Of course, the middle one is not maximum, but we don't know if the left one is maximum or the right one. But we can guess which one would be critical. Let's assume some numbers here. Let's assume PC is 1 kips, okay? In that case, how much would be the value of the shear force on the left side? That is 4 plus 1/7. It's almost like 4.1, 4.2, something like that. On the CD part, the shear force is going to be 3 plus 6/7. It's about like 3.8 something. So if PC is a 1, the left shear force is going to be maximum. But look at P sub B. It is given to be 7. And I'm expecting PC to be in the same order of magnitude. In that case, Vmax is going to be -3 plus 6/7 of PC. That would be maximum if PC is larger than 7/5 of kips. That would be equal to 1.4 kips. Now let's determine the section properties. We need to ensure that maximum stress is not exceeding 850 psi. Maximum stress happens at the middle of the section. So Q should be calculated for the centroid of the section, or Q max. I is just for the entire section. That would be BH cubed over 12. With the given B and H, that would be equal to 36 inch to the 4th. Q max is BH squared divided by 8 for a rectangle. With the given B and H, that would be equal to 9 inch cubed. Alright, now I'm gonna plug that into the stress equation and make sure that stress is not exceeding the allowable stress. Tau max would be VQ divided by I and T. T here is the thickness of the cut section, which is B, the width of the rectangle. Now, this stress has to be smaller than the allowable stress. Alright, now let's plug in the values. V max is -3 plus 6/7 of PC. Negative sign, we are not going to carry that over because sign of shear stress doesn't matter. By the way, I'm going to multiply that by 1000 because force is given in kips, but stress is given in PSI. So I'm going to convert this into pounds. Q max is 9 cubed inch. I is a 36 inch to the fourth, and width of the section is B, or 2 inches, and that has to be smaller than 850 psi. As you can see, the only unknown is P sub C, and if I solve that, PC is limited to 4.43 kips,